Alright, you guys, let's see how you did on this Chapter 3 review notes. So in the first part, it's really important that you guys notice they only tell you that y and z are parallel. Okay, they don't tell me that w and x are parallel. So I want to be sure I'm only reaching conclusions based on y and z being parallel. So our first one is angle 15 and angle 17. So let's take a look at angle 15. Let's trace it over. Okay, there's 15. Let's trace over 17. Okay, so you guys should say that they're using x as the transversal and y and z are our parallel lines. So 15 and 17 are a pair of corresponding angles, which means that they do need to be congruent. Okay? Number 2 now, we're looking at angle 7 and angle 12. So let's go ahead and trace over 7 and 12. Now I am willing to bet some of you put congruent for this one. The problem is 7 and 12 are a pair of alternate interior angles, but look which lines they're using to be those interior angles. They're using lines W and X, which I do not know are parallel, so I cannot make a conclusion. Okay, so no conclusion for number 2. Okay, number 3, we're talking about angles 2 and 3, so let's try tracing over those. There's angle 2, here's angle 3. So good, they're using W as our transversal, and we can see that it is y and z as our set of lines, which we do know are parallel. So 2 and 3 are a pair of same side interior angles, which means that they are supplementary. Okay, going on to number 4 now. We are looking at angle 6 and angle 11. So I'm going to trace over them in red. So here's 6. Here is 11. Okay, so we can see this is their transversal, and they are using y and z as their set of lines, which we know are parallel, so they must be a pair of alternate interior angles, which when the lines are parallel, we know are congruent. So 4 is congruent. Number 5 says if triangle ABC is equiangular, then the measure of angle B is always 60. We actually had that as one of our theorems we proved already. It was a corollary to one of our theorems. Number 6, the 3 vertices of a triangle are never collinear. If they were collinear, obviously, they're just going to make a line when we connect them, not a triangle. 7, 2 skew lines are never coplanar. That's their definition, that they are non-coplanar lines. And 8, if 2 parallel lines are cut by a transversal, then same side interior angles are sometimes congruent. Okay? Because remember what we know about them. If we have parallel lines cut by a transversal, we know that those same side interior angles are always going to be supplementary. Now, in one special case, where they're both 90s, will they also be congruent? So it's sometimes. Okay, 9 wants us to find the sum of the interior angles of a polygon with 12 sides. So we use our formula, n minus 2 times 180. So in this case, n is 12 because of the 12 sides, so 12 minus 2 times 180, so 10 times 180 is going to come out as 1,800. Okay, number 10, find the measure of each interior angle and each exterior angle of a regular polygon with 18 sides. So I'm going to actually start with B because the exterior angle is easier to find because we know that sum for the exterior angles is always 360. So to find each one, we just divide by how many sides it has, which is 18. Okay, that's twice. So 20 for part B, that's the exterior angle. And then remember what we learned about interior and exterior angles is wherever the edge of our shape is, there's an exterior, there's an interior one, they have to always be supplementary. So if the exterior one is 20, we know automatically that the interior one has to be 160. Okay, let's take a look at the back side. Number 11, go ahead and start with the fact that we can see x and 70 are forming a straight line together. So x automatically has to be 110. Now to find y, you could find this missing angle in the triangle and find what's supplementary to it. Or you could remember the theorem that said this exterior angle is going to be equal to those remote interior added together. So just add 30 plus 110. It comes out as 140. If you forgot that theorem and did it the other way, you should still get the same answer. Okay, number 12, notice we have a set of parallel lines. Here's a transversal coming and cutting through. There's a pair of alternate interior angles. They must be congruent. So A has to be 55. To find B, 55 plus 45, we've used up 100 degrees in that triangle. So this one has to be 80. and B and the 80 are vertical angles with each other, so they have to be congruent. So B must be 80 as well. Okay, for number 13, why don't we start with this triangle I'm outlining in red. So far it has a 30 and a 60 degree angle, so it's 90 degrees so far. It means we have 90 degrees left right there. Ends on the other side of that, forming a straight line. So it also has to be 90 degrees. Okay, to find the 30, let's look at this small triangle here that I'm outlining in blue. If that's a right angle, we know this one's going to be a right angle as well. So we've used up in the small triangle, 90 plus 30, we've used up 120 degrees, meaning where M is, we have 60 degrees left. Okay, for number 14, what we need to do is we see that that angle is marked as 90, so that means there's 90 degrees left in our triangle. So x plus 4x plus 5 must add to those other 90 degrees for the triangle. So 5x plus 5 must equal 90. Subtract the 5 over, so 5x equals 85. Divided in, it's going to come out as 17. Okay, number 15, I can see the y and the 110 need to be supplementary here, forming that straight line. So y is going to have to be 70 degrees. Okay. What we could do to find the other one, you could use the triangle, or you could use the fact that these remote interior have to add to the exterior. Either way, you're going to see that x has to be 60. Now 16 for the regular hexagon. Notice that y here, that's an exterior angle, and x here, that's an interior angle. So I'm going to use my rules for regular polygons here. So remember, the external one is easier to find. A hexagon, that's 6 sides, so we can just do 360 divided by 6. So 60 for y, which is my external angle. And remember, if this one's x, this one's going to be x too. And look, we can see that they have to be supplementary. So if the external one is 60, the interior one must be 120. Okay, number 17, we're given 3 values for the angles and told that they're in a triangle together. So we know they must be adding up to 180. So let's set it up. Let's add up those values and set equal to 180 since they're in a triangle together. So that combines to 7x plus 12 equals 180. Subtract your 12 over, so 7x equals 168. Divide your 7 in, and it goes in 24 times. So now to find the numerical values, we need to plug back in. So the measure of angle A is 3 times our x, which is 24, plus 3. So 3 times 24, that's 72 plus 3, so 75. Measure of angle B was 2x plus 8, so 2 times our 24 plus 8. So 2 times 24 is 48. 48 plus 8 is going to give us 56. And then measure of angle C was 2x plus 1, so 2 times 24 plus 1. So 2 times 24, 48 plus 1 is 49. So those are our answers for number 17. And last one, number 18 wants each interior angle. Tells us it's 170. So if each interior is 170, I want you guys to think what each exterior angle would have to be. Since they have to be supplementary, it would have to be 10. And then to find how many sides, it's easier to do it based on the exterior angle, because all we have to do is 360 divided by each exterior angle, which is 10. And it's going to come up as 36.